to do something, because it's very hard to kind of impose a mathematical model on what's going on in this system, believe me. There's so many variables coming into play, and including the alignment procedure and stuff that's kind of out of our control, that I had to fall back to a pretty general technique. So I actually borrowed this idea from the clustering literature, hierarchical commutative clustering, where you group things together iteratively in accordance with some similarity metric. Now here, similarity is kind of being used in a strange sense, because what I'm going to do is use that to group templates that are candidates for being merged. And when I cluster templates together, I'm actually going to go ahead and merge them. So all my sets that I'm clustering together at any given time are only going to have one element. And the idea then is to parameterize the similarity metric and try to tune the parameters. Okay, so this is actually kind of an adaptation of the exponential model used in maximum entropy modeling. I won't go into detail except to say that there's a parameter here for each of these questions that the learner could ask, and this actually does give you a probability as a result. So as I was saying, I had to take very general techniques. So I did a greedy search technique and an annealing search, where you simply would permute the existing similarity metric and then run the system end to end. If it improved your performance, you kept the new metric. And if it hurt your performance, if you're doing a greedy search, then you would throw it out and go back to your old metric. And if you were doing an annealing search, you would still accept the new solution with some probability that's inversely proportional to the decrement of performance that you got, so that it's just a way of staying out of local maximum. Well, I ran a number of experiments and often got learning curves like this when I use curves in a loose sense. It may look like there's actually a slight bit of a curve here, but if you look at, so here we have iterations on the x-axis and f-score on the y-axis. And if you look at this, you can see that this is essentially a straight line. We started off at about 58.7. We got down early as far as 57.7, and we ended up at about 59.8. We squeezed about an 1 point of f-score above a randomly generated metric, right? This is on the training data, right? This is like, probably not going to buy me anything on test data, right? So this is like, okay, now I'm really getting frustrated, right? I tried eyeballing the data, I tried supervised learning, I tried this, and nothing's working. And I thought, boy, I need an explanation here. The one thing that all these experiments have in common is that my definition